Good morning, 8th and 9th grade science class. Starting a new model, and we will do from page 311 to 324. And so that will mean you'll do on your own, on your own boxes, you'll do 2 of those if you go by that. So if you turn back to the beginning of the module, we are going to talk about the weaker force. Now, we're still talking about force, the electromagnetic, but we're specifically looking at the weak force, and then later we'll look at the strong force in this unit. But the weak force is basically in the atom. So if you look at page 311, we'll talk about the atom, and we say these things like they're facts. But really, to tell you the truth, they're only theories. Because you remember earlier we discussed that nobody has seen an atom. Nobody has been able to get a large enough microscope or have a large enough magnifying glass. No human being has seen an atom. Now, we've only taken the results of what we've observed, and we've concluded that an atom is made up of neutrons, protons, and electrons. And so I put it up here. The atom is the protons, the neutrons, and the electrons. Now, think about the weak force here. You see, last time we studied about the electromagnetic force, and we talked about the positive and the negative. We have the same thing in an atom. Exactly the same thing, except it's just real weak. Now, don't even think of getting a shock if you touched it, okay? It's beyond, it's so mild. And so I put the positive. I put protons. This is vital stuff for you to keep in mind. The protons and the neutrons are 0, and the electrons are negative. So the neutrons are nothing, or 0, and that's actually how we got the name, neutral. The neutrons aren't positive and they're not negative. And so let me just. You can look at your example, and then I'll draw you a picture as well. If you turn the page over to 314, on page 314 you get a picture, and you have the protons and the neutrons in the middle. And then out around here, you have the electrons. So you have your positive, let's just go positive. I got some big ones, some little ones. Here's another positive. And these other guys are zeros. So the neutrons are 0, and the electrons out here are your negative charge. These are negative. And while your picture doesn't do a good example of it, these electrons should be way far out there traveling around. But there is this attraction again. You remember, negative and positive attract. So there is this traction between the protons and the electrons that keep the atom together, or that hold the atom from flying apart. Think about the neutrons too, not just spinning around in a circle. Think of a 3D picture. They're going this away, and some are going this away, and some are going this away. They're not all just going around and around and around like this. Some are going like this, some are going like this, and they're all going around, the protons and the neutrons. In the center, if you look on your page 314, the center, you have the nucleus. The nucleus of an atom is made up of only 2 of your elements. Oh no, I shouldn't use that term, sorry. Only 2, protons and electrons. Protons and electrons form your nucleus. That's the center of the atom. Then you have the atomic number. If you look at page 317. On page 317, you will have the atomic number. It's the number of protons in an atom. Now, if most of the time protons they are positive, and so I'll just hang on. I'll just keep that. The protons is the atomic number is how many protons. Then you have the mass number, and the mass number, and you'll just turn your page again now from 317 go to 318. On 318, the mass is the sum of the neutrons and the protons. So you have to add these two together. To get the mass number, you have to add the protons and the electrons. And most of the time it's the same. So if you have 2 protons, you'll have 2 neutrons. So your mass number would be 4. If your atomic number is, let's say, 7, then you're going to have 7 plus 7, so your mass number would be 8. In most atoms, they're the same. Now, there are a few exceptions. Don't think that every time, if you know the atomic number, the mass number will just be doubled. Whoa, how did I double 7 plus 7 and get 8? If that's true, I should have 14. The mass number should be 14. Now, there are a few exceptions. Right here, do you know how to pronounce that word? It's really not too hard. You got I, okay, so you just say isotopes. That's, don't say top. Okay, here you got top. See the little word top, and here you got so, and so it's pretty easy. You can just about say isotope. It's not quite isotope, and then it's plural, isotopes. Isotopes are atoms that do not have the same number of protons and neutrons. Okay, so your atomic number might be 7, and the protons would be 7, and then maybe your neutrons would be 8. And those atoms, then your total would be 15. So those atoms that don't have the same, they're called isotopes. Isotopes, and you have an example of that on page 318. You have the helium, and the helium has different numbers of neutrons. The atomic number stayed the same for helium, which is 2, but some neutrons had, some forms of helium have 2 neutrons, some have 1, and some have 3. If you go over to page 319, the top of 319, you have isotopes. Then the next word you have is element. And an element is a collection of atoms that all have the same number of protons. Okay, to get an element now, you will take a whole bunch of these atoms that have the same number of protons and neutrons, and you put them together, and you start piling them together, and piling them together, and piling them together, and finally you get something big enough that we can see. And we call that an element. And you say, oh, what's an element? I don't know what an element is. Well, that's not too hard. Scientists have made that easy for you. Turn your page to page 321, and you have that table of elements. Now, I can remember going to school and having this page of elements, and I'll be honest and tell you that most of it was just numbers that I didn't understand. That wasn't the teacher's fault. That was my fault. So if you look at this table of elements, you say, oh my, what's that? I don't know. If I look at the first one, number 1, it says it's H, capital H. I don't know what that stands for. Does that stand for hat? No, that stands for helium. All the elements are abbreviated. And I don't know if our book has a chart to tell us which ones, what they mean or not. Now, right now I don't see a chart. But if you look, each element has a number on it, and that has to do with the mass number, and as well as the proton, the atomic number, the number of protons in the element. And so I put table of elements. You will need to refer to that to do some of your work, and also it's just a chart to go by. He says that in the book here, he says, whenever I talk about the thing, I just refer to it as the chart. Okay, all scientists use this chart to talk about elements and atoms and protons. If you look over on the page 323, you have the model, the Bohr model of a calcium atom. And so there it gives you just a little bit more of an illustration of how the electrons go around the center of the protons and the neutrons. I think that's all I have. You enjoy your lesson. If you come back this weekend, when you do come back this weekend, bring your science test along so I can check it. I got a couple down there on the table already, so a few you have returned them. Thank you for that. Today we will stop at 324, and then I hope to let's see, this is Wednesday. On Friday, I hope to go to finish this model back to the part where you have the study guide. So we will take 2 lessons or 2 days to do this model, and then that means that next week we will do study guide and test again. Thank you.